So, good morning, everyone, and welcome back to the session on your data structures, Unit 2, that we were discussing about here. So, the third part of your Unit 2, what we have here is something called as double linked list that we were discussing exactly from the past two sessions. And today, we people are going to discuss about something called as deletion operation. How can we perform deletion operation on your linked list? So, I mean, double linked list that we are going to do. See in this particular session. So in the previous session, we were actually discussing about inserting a node, right? And in that, we have seen that there are four cases we do have. And in that, the first two cases, we already discussed it. That is nothing but inserting a node in the beginning and inserting a node in the end. That was somewhat easy that we can consider it. Now, the third case, what we have is inserting a node after a given node. So whatever the value I'm giving, let us suppose this is the linked list I have, and I wanted to insert a value here in this particular point. Means after number 3, after in the linked list, after the data element 3, I want to insert one more element 9 here in this particular case, and this is what I'm going to do it exactly here. So how can we do this? That we are going to do, see here. So first thing, I think if people know what we need to do here, we need to first create a node, and that is nothing but the new node whatever we are having here, and within this first we will be giving the value 9, isn't it? And this time the previous and the next value of a new node will not be making it as dull, because this particular node we are going to insert here. So definitely the previous block and the next block of this particular new node should be empty, because we will be getting some addresses that we need to write it to this particular location. So we are not going to delete it. Okay, so we are not going to fill that with something called as null character or something like that. So first we'll create a data element. So we'll create that particular node, and then, so this is the first step, allocating a node to that. So we have created it. You can just simply escape this. This is not existing here, this one. So that is by mistake, I have kept the previous one. So here, so the previous block and the next block is empty in this. The only thing is I have filled the data block for this particular. So I have created this new node. And in this new node, I simply added the data, whichever I want, 9. So right now I have to place it here in this particular location. So how can we do it is, first thing is we have to create a pointer variable PTR. And initially it is pointing to the first node. So what is the first node we have here? The start wherever it is pointed. So this is the first node. Now we will be using a while statement, a looping statement, to go to the place where exactly we want to insert that particular node. Okay, so where I want to insert that? After number 3. So this particular pointer should reach to this particular location. So till then I will be traversing it. So you know how to traverse it. While pointer data not equal to null, keep on traversing it. And finally you will reach this particular location. You can see here the pointer has reached. Now what you have to do is simply insert that particular node. So how to insert it? Simple. The new node previous address should consist of the address of this particular node, and the next block should consist of address of this particular node. Same way, this particular previous, this is the pointer where the pointer is pointing. The next block of that should consist of address of this particular node, and same way the previous block of this particular node should consist of address of this particular new node. That is what we have to do exactly here in this particular case, and that can be done using a logic here. So what is the logic we are exactly using here is nothing but this one. I will show you practically here so that people can understand here. Now this is a code, and this is the new node which I have created. I want to insert here. So the process is very simple, like whatever we have discussed till now. So we'll be first creating or declaring the new node, I mean the structure node, so which consists of new node and pointer. So enter the data which you wanted to write. So what is the data here? Number 9. And enter the value after which the data has to be inserted. What is the data which I wanted to insert in this particular case? Something called as after number 3. So here the value will consist of something called as 3. Now, after this, what I have to do, I am creating a new node here. So what is the node I have created? This is the new node I have created. So in this, I am going to place only the data number here, something called as 9. How to do that? New node arrow data equal to num. So this is a new node and I'm accessing the data block. So new node data equal to number. Now I'm going to take a pointer. Now the pointer will initially assign to what will initialize it to start. So right now the pointer is at this particular location. Now I have to traverse it, right, until I'm reaching to this particular value. How to do it? Very simple. While pointer data not equal to value, you will be traversing it. So pointer equal to pointer next. So what is the data that is present in this right now? 1, isn't it? And 1 is not the value which I'm searching. What is the value here? 3. I'm searching. So 1 is not equal to 3. Condition is satisfied. Pointer equal to pointer next. So now the pointer will be moving to the next node, whatever we are having. So right now the pointer is at this particular location. Again, I will check while the pointer data. So this is the data 7 not equal to 3. Condition satisfied. What I have to do? Pointer equal to pointer next. So just move to the next block. So I have successfully reached to the block. So while pointer data not equal to value, but this time 3 is not equal to value. What is the value here? 3. This time the condition fails. What we have to do? Simply skip and come here. So now what I have to do here? Now look at this particular figure, how I'm going to do. Now, do I have to do anything with this? There will be no problem since this is a new node I have created. I will not be having any problem to store the information in the previous block and next block. Let us suppose, let me write. So this is the address number 100, 200. This is 300. OK, let us suppose the new node I have created, the address is 250. So here I'm writing as OK, I'll write it as 400. So this I'm writing it as 400 and this is your 500. Now what is the address present here? It will be 400 and here it will be consisting of 500 and here you'll be having the address of something initially 300 because we just created this new node. We did not provide any connection. Now the next block will here consist of address 400. I mean the address of this particular node. OK, and this will have 200 here. This will have 300 and this will be having 200 and this will have finally 100. That's fine. Now you have created a new node here. Now I want to first thing what I have to do is I wanted to fill the previous block of this particular new node. How can I do it? New node previous equal to what is the address this previous block should consist of? Address of the previous node. What is the previous node? This is the node. And what is the address here? 300 and it is present in which particular variable? Pointer variable PTR. So simply equal to PTR. So PTR consists of 300 and that I'm storing in a new node previous. Indirectly what happens here? You're establishing a link now. Now I want the address of next node. I mean, the next block should consist of address of the next node. What is the next node address here? 400. But I don't have any variable like pointer which can consist of address 400, right? But then how can I write here 400? The question here is, how can I write a 400 in this next block? Of that case, what I'm going to do is, look at this particular node, the pointer node. Pointer next block consists of address 400. Please look carefully here. Pointer next block consists of address 400 means it is pointing to this particular node, right? And in this node, the previous block, whatever you're having, that I wanted to replace. OK, I just wanted to write it here, right? OK, so if you see here, pointer next block consists of address something called as 400. So I think you people know how to get a 400 here, isn't it? How can we get a 400 right now? So new node next block equal to, can I write pointer next? Is it possible? So pointer is pointing to this particular node. So pointer next block consists of address 400. So that I am assigning here. So that I'm assigning to what? New node next. So new node next means this is the block. So you people got it 400 successfully. I'm able to get the values here 300 and 400 with the help of a single steps. Two steps here. What are the two steps? New node previous equal to pointer. Pointer consists of address 300. That is, you have got it. Now new node next equal to, I mean this block equal to pointer next. What is pointer pointing to? This particular node. And what is the address present in the next block? 400. So directly you got. So indirectly you have established a link here in this particular case. OK, I hope you got this. Now what I wanted to do, now the next step what I have to do, I have to execute two more steps here. I need to replace the pointer next block with new node. That is 250 should come here. Here also I should get 250 instead of 300. Now, how can I get this? So I am not going, this one we can do it very easily. Pointer next equal to new node, you will get the value 250. But if you see here, for this particular node, I don't have any variable to access. Then how can I change this particular previous value? the previous block of this particular node. So first I had to change this, then I will change this. How? Just have a look. Pointer next. First, I'm writing pointer next. Please understand this very carefully. Pointer next means what is the value present in the pointer next? 400. Now means I am right now pointing to this particular node, this one, this particular node 400. And in this, what is the value I want to change? The previous block. So how can I access that previous block? Is simple. Arrow previous. I hope you are getting it. See, pointer next previous. What is pointer pointing to this node? Pointer next consists of 400. So I am coming to this particular node. And in this node, I am trying to access the previous block. So pointer arrow next arrow previous equal to what is the value I want here? New node value 250. So simply equal to new node. This is what you people have to do. Please remember this. Okay, whenever you don't have a variable that is actually assigned to this particular node, simple thing, pointer next. So what is the next consist of 400, and that 400 means you're locating this particular node, and in this I want to access the previous block. So pointer next previous equal to new node. What is the address we have for new node? 250. That I'm assigning here. So indirectly now what did I do is I simply replaced this 300 with 250. Finally, this part is also completed. This is completed this. And the last one that is left here is something called as this one. How can I replace it? Pointer next equal to new node. Very simple, I think. Pointer next. So what is the pointer next consist of value 400. This I want to replace with the new node address. So simple pointer next equal to new node. So what is the value we have here? 250. That 250 I'm assigning to this pointer next. So simply I'm going to replace this and I'm going to write it as 250. Fine, your task is completed. And finally, what you have to do? Return the starting position, that is this position. So now you people can see this node is pointing previous node 300 means it is pointing to this particular node, and the next node is pointing to 400 means this one. Okay, sorry for the interruption. It usually comes at this time. Yeah, completed. Now, and if you see here, pointer next consists of address of the new node, that is 350. So 250 that is coming here. And same way, this node consists of address of the previous node as 250. So finally, I'm able to insert a value 9 in between. So this is how exactly you can see here. After 3, you got something value here 9. So this will consist of address of this one, and this will consist of address of this one, and this is consisting of address of this, and this one is consisting of address of this particular node, whatever we are having. So this is the way how exactly people are going to execute it. I hope you people got it. So only these are the steps you people have to remember. First thing what you have to do is new node previous equal to pointer, because here new node we don't have to do anything with this. So new node previous equal to this particular node, that is 300. So simple new node previous equal to pointer, so you will get 300, and new node next equal to I want the address of 400. Earlier this address was present in this, so pointer next, so that's why I use it pointer next. So finally I'll getting here 400. Then I have to replace these two with the help of these two particular statements. So what is the statements? Pointer next previous, you can see here there are two arrows here, pointer next. So pointer next means this will consist of initially 400. So it will jump to this particular node, this one. And here it will access the previous block. And there he is going to replace with the new node address. What is the new node address? 250. So you got a 250 here. This address you people can change very easily. Pointer next equal to new node. That's it. So the address is 250. That address will come here. Automatically a task is completed. So this is a way how you people can perform something called inserting a node after a given node. Now I want to do it before. Same process. Okay, but there is a small modification. Same thing, I want to insert a node 9, but this time I want to insert here before 3. Okay, earlier I inserted after 3. Now I want to insert before 3 here. So process is same, but small logic is there which we had to take. First thing, we will be initializing the memory for that. So both the spaces will be empty. We'll take a pointer and this pointer will move to the place before which I want to particular location. So you can see here. So pointer is in the starting position. Now pointer came to that particular. Now what I have to do, I have to simply add it up. That's it. Okay, so this is the way how exactly we are going to do it. But here there's a small logic here which you people have to modify. I mean, you people have to see here in this particular case. So here is the same logic. There is no much difference. Same pointer will be pointing here. So first I'll initialize this the value. Let us suppose new dot consists of address 250. This is your 100, 200, 300. This is what I want. So here I have initially 300 and here I'm having initially 200. So first I'll create a new node. So new node previous equal same pointer data. So new node next equal to, so this time the pointer is here. So can I get the address in the next block here? How can I get it? New node next block. So next, what is the new node next block here? This one equal to pointer. So pointer is the one which consists of address 300 here. So PTR. So what happened here? You people got the address here 300. Now what did I want now? So I want the address of this one. What is the address here? 200. This is the address I want. But this address is present where? If you see here, that is present in the previous block. Can I write something like this? New node. I mean this node. Previous block equal to previous block equal to. So what is the address I want here? 200 I want in this location, but this 200 is present here. You can see here. So can I write equal to pointer previous? Pointer previous. So pointer previous consists of value 200 means indirectly what happens here? That 200 I'm storing here. So indirectly a link is formed between this and this. Fine. Now what I have to do? I need to replace the values here. This 300 should be replaced with 250 and this 200 should be replaced with 250. Now replacing pointer previous with this is quite easy. But if you see here, this particular node is not having any variable to access it. So first I will try to change this number, this 300, I will try to change with 250. How can I do it? Same like the previous one, how we did it. What is that? Pointer. Let us look at this particular node pointer. This pointer previous consists of 200 means this particular node. So pointer previous. So pointer previous consists of address 200. So I am coming to this particular node 200. In this, what is the address I want to change? The next block. So pointer previous next equal to, what is the address I want here? New node address. So new node. Okay. So now what happened? What is pointer previous here in this case? In this case, what is pointer previous? If you see here, where is the pointer? Here. Pointer previous consists of address 200. So I'm jumping to this particular 200. 200 next. So this block. Earlier it consists of 300. Now I'm giving equal to new node. What is the address of a new node? 250. So that 250 is coming in this particular location. Okay, so pointer previous, the previous block consists of 200. So I'm jumping to this location. In this, the next block 250 that I am using this particular arrow next equal to new node 250. So that 250 I'm adding it. Done. Now what I had to do? I had to replace something called as this 200. I had to replace now this 200 with 250. How can I do it? I think this is simple. Pointer previous equal to new node. So pointer previous equal to new node. What is the address of new node? 250. Where I'm storing pointer previous. So pointer is pointing here. So 250. Your task is completed. Your value has been inserted. You can see it's very simple. But remember, before performing this operation, pointer previous equal to new node, you have to perform this pointer previous next. So pointer is pointing to this node. Pointer previous will consist of address of this one, this particular node, and that next block equal to new node 250. Then only this can be replaced. This is the only step which you people have to remember perfectly. Remaining all is very, very easy of inserting after the node or inserting before the given node. Remaining is everything is very, very easy. I hope you people have got it how exactly it is going to work on. Now come to the deletion. Okay, I'm not going to the slides now. I'll directly show you here itself the code so that it becomes easy for you people to how it exactly works. And then we will see that particular code, how to execute and all. Now, if you see here, deletion. The next topic, what I'm going to discuss here is something called deletion. Now, here also we actually have 4 cases. So if you talk about deletion, okay, this is the code what we have discussed now, just now, inserting before a given node. Now, if you come for the deletion of a particular node, we are having 4 cases here, same like the previous, like single linked list. Case 1 is deleting the first node. Case 2, deleting the last node. Case 3, deleting a node after a given number, deleting a node before a given number on a node. So first one is deletion. Okay, I'll directly go here. I'll explain it. This is a code for that. Sorry. Yeah. Deleting the first number what we are having here exactly. So this is a code, very easy. This is a thing what the linked list, I mean the double linked list I'm having here. You know that the address of this is 100. Let me write it up. 200. This is 300, 400, 500, and let us suppose this is 600. Deletion in the beginning and the ending will be same. Very easy it will be. Okay, let me write it up first. What is the address we will be having here? 200. And here you'll have 100. Here what you are going to have 300 here. And here you'll be having 200. And here you will have 400. And this side you will be having 300. Address of a previous node. And here you'll address of next node. What is that? 500. And here you're having something called 400. And here you're having 600. And finally you're having here something called as 500. Pretty good. Now, I want to delete this particular node and make this as node number 1. And the start should be pointing at this particular location. This is what I need to do. Okay. I just wanted to delete this particular node. What is the node? This is the node which I wanted to delete it. And this I wanted to make this as the first node in the list. How to do it? Very, very, very easy it is. First thing what you have to do is you people have to declare a pointer variable. Why? Because once you're deleting this node, as I told you, when we are deleting a particular node, we need to free the space that is allocated to that particular node. So definitely it should be pointed with something. When start is coming here, so this node, we don't have any variable for accessing. So how can we free it? For that purpose, I'm declaring a pointer variable here, PTR. I hope you're getting it. So first thing, pointer equal to start. So right now, pointer is at this particular location. Now I have to delete this particular node, right? How can I delete it? It's very easy. Start equal to start next. What I have written? Start variable equal to start next. Now look at here. Start next is saying start is pointing to the first node. In the start next, it consists of address of the next node. What is the address here? 200, isn't it? So here start will be pointing to start is equal to how much? Start next. That is nothing but the next address 200. So now the start has skipped from here and it is pointing to this particular location with the help of this particular step. Now what I have to do, you people know that if this becomes the first node, the previous block of this particular first node will be null. It should not consist of any address. So means this should become X. As you can see here, the first node previous is X. Now this has become the first node, the previous should be X. How can I make that? Simple. Start is right now pointing to this node. So start previous equal to null. So what happened here? Start previous is null. So this time earlier it is having address 200. Now I am making it as X. So this becomes your first node. Now what happened? This is totally detached. The first node is totally detached. And what is the variable that is actually pointing to this particular node is pointer. So what I have to do now, I have to remove the memory that is allocated to this particular node. So free pointer PTR. So whatever the memory is allocated, that is the memory 100, this memory will be removed. Automatically this memory is freed and that memory can be used by some other process. This is the way how exactly this particular thing works. Very, very simple, isn't it? Only thing what we did here is nothing but, once again I'll explain it. So this will consist of 100, this consists of 200. So what did I do initially? Start equal to start next. Next consists of address 200. That I am assigning to the start. So simply start escaped from here, jumped here. So here we are left only with the pointer variable. Now what I have to do? So since this is the first node, the previous block of this particular first node should be empty, that is null, like this x. So what I have to do, it consists of address 100, so I have to replace that. So start previous equal to null, that is what I'm doing. Start previous block equal to null, so this will be replaced now. So this will consist of what? -1, or you can also call it as x. So this is totally detached from this. Now this is again replaced with a pointer. Now I need to free that particular thing, the space that is allocated to it. So simply free pointer. So this is removed. Now this becomes your node number 1, node number 2, this is 3, 4, and this is node number 5. This is a way how you people can delete the node from the beginning. And if you talk about, if you come across something called deleting it from the end, same process. But only thing is, here you will be declaring a pointer variable, and this pointer variable will be traversing till it reaches the end. And you people know how to traverse. So where you are getting the next block of a pointer, I mean a node as x, that means that is the end of that particular node. So while pointer next is not equal to null, keep on traversing. So finally the pointer will reach here in this particular case. Now what I have to do here, I want to delete this node. I wanted to delete that node. What does that indicate? The previous node, next block, I mean this one should consist of X. Then only it will be deleted, isn't it? So what is the addresses we'll have? Let me give the addresses first so that it becomes easy for you people to understand. So first address I'm giving here is 100, 200, right? This is 300. We were taking from the beginning. This is 400, 500, and this is your 600. Now, what is the address we have here? 200. And what about here? 100. And here we are having 300. And here you'll be having 200, and this is 400. And if you talk about here, 300, 500. And here you'll be having 400, and this time you're having 600, and here you are having 500. Now I have taken a pointer here. Pointer is initial at this particular location, while pointer next not equal to null. So I'm seeing the addresses. Where I'm getting this x value, so this is 500, and the address of this particular node is. So when I'm getting a particular, I'm reaching to this particular x value, that is null value. That means I have reached the end of a particular node. So while pointer next not equal to null, keep on incrementing. So pointer will come here. In the next iteration, pointer will be coming here, then finally here, and the last node. Now while pointer next not equal to null, it is null. Condition fails. Come here. So what I have to do now, this is what you people have to concentrate. Now I want to remove this node, right? How can I remove this particular node? This node is attached with the previous one. Means this block consists, what is the address of this particular node? Last node 600. Where it is present? The next block of the previous node. Now this I have to erase here. This 600 I have to erase, and there I have to write something called as null. That is -1. How can I do that? So I have to access this particular node. So do I have any variable which can access here? I don't have, because the pointer is pointing to the last node here. So how can I do it? As I told you in the previous, how to insert after a given node and previous node, same way we are going to perform the operation here. How? Pointer, which one? So this is a previous node. What is the address present here? What is the address present in the pointer node? Here, that is a previous block. So pointer previous means what is that? 500. So this block, and in this block, in this node, the next block should consist of null. So that means the next block should consist of null. So that is equal to next equal to null. This is the only code which will be removing this element from here. Pointer previous block. So what is the previous block? Consists of address 500. So this is a node 500, and in this node the next block, so the next block should be replaced with null. Initially it was having 600, but now I have written null means it will be having -1. Simply I have detached this particular node, and Since I have detached this particular node, but I did not free the memory. So this memory has to be freed. How can I do it? Very easy, using a free function, free pointer. Because that variable, I mean, this particular node is accessed using this pointer variable. Simply done. Only two steps you people have to remember. But this is what you people have to remember here. This is somewhat you people have to practice it so that it becomes easy. It is actually very easy. You don't have to get confused also here in this particular case. Let me explain it one more time. So this is 400, this is 600. So this will consist of 500, this will consist of 600. So first I have a pointer here. This pointer, first I'll bring it to the last node. So what I'm going to do is whatever the address present in the next block of the previous node, this should become x minus 1. That is null value. Then only I can detach this. So how can I do it? So you know that the pointers previous block consists of address of the previous node. So pointers previous block consist of address of a previous node, this node. So what is that 500? So now you have come to this particular location. In this particular node, the next block you want to replace. So simply arrow next equal to what is the address you have to give here? Simply null. So what happens here? This 600 is getting replaced now. This 600 is getting replaced with -1. Or you can simply write x, whatever you wanted to write. Simply enough. So what happened? This is got detached now. There is no connection between this node and this particular node. Now I had to remove the memory space allocated to it. What is the slot given here? 600. So this 600 I had to free it. How can I use? I can use a free function. Now this node is accessed using a pointer variable. So simply ptr. These are the two steps you people have to remember, and your task is completed. Very, very easy. Okay. And the next thing what we have is we want to delete now. So before we have seen deleting the first node, now we have seen deleting the last node. Now we will be focusing on deleting after a given node. Okay, so after a given node means this is a node. I want to delete this particular node. You're seeing this? This is the node which I wanted to delete it. So this is node number 1, 2, 3, 4, 5, 6. So after number 4, whatever the node is there that I want to delete, that is 7 I want to delete in the list. What is the list we have? 1, 3, 4, 7, 8, 9. So after 4, whatever the element is there, this one I wanted to delete it. That is my task. So how to delete is same way, same like the previous. You will be using a pointer variable, and this pointer variable will travel to the node after which you want to delete. That is node number 4. You know how to do it. While pointer data not equal to 1, pointer equal to pointer next. It's very easy. So you will be traversing and you will be reaching that particular node. Now, how can I remove this particular thing? Oh, sorry. How can I remove this particular node? It's very simple. I have to simply remove, overwrite the address that is present in this particular pointer next, and this point and this particular the previous block of this particular node, and then automatically this will get eliminated. Simple. Then only there is a connection. So this node, this node should consist of address of this one, and this should consist of address of this one, the previous block. That's all. Your task is completed. So how can we do that? Let's see how we can do that particular thing. Simple. First thing what I'm going to do is first I'll take a temporary. We are going to use a temporary here pointer. Apart from pointer variable, I'm going to use one more variable, pointer variable called temp. Why I'm taking means in this I'm going to store some information. What is that is pointer next value. So when you reach this particular node where I had to delete it, temp equal to pointer next. So, okay, let me write the values here 100, 200, this is 300, this is 400. Okay, this is 500, this is 600. So what I have to do now? So first let me write it up how here we are going to write. So this will consist of 200 and this will consist of 100. So this will consist of 300 and this will be having 200. And what is the address we'll have here? Initially we are having address 400 and this will be having address 300. First initially we have a link here. Then this will consist of 500 and this will consist of address 400. and this will consist of 600 and this will consist of 500. Initially, this is a linked list what we have. Now I want to replace it. So how can I replace it? The first thing what I had to do, I had to take a pointer variable. Pointer initially pointed to start. And now we'll increment it until to the value where after which I had to delete it. So pointer, what is the value I'm giving here? 4. So I'm coming to this particular location. So while pointer data not equal to value, so pointer. So pointer will be traversing till it is reaching to the value where it is 4. Now what I have to do, I'm using a temporary variable. Temp equal to pointer next. So what is the address we have in pointer next? You can see here. Sorry. See here, what is the address we have here? 400. So that 400 I am storing in this particular location. Why I'm storing that in temp, I mean that 400 in days, because once this particular node is detached, I need to free the memory allocated to it. But if I'm not having any variable, I mean pointed to this particular node, I cannot try to overcome that. I mean, I cannot try to free that particular memory space. So here, the address of this particular node, that is 400, I am storing in a temporary variable so that I finally can free it up. You can see a free temp. Then only I can free that particular memory. So initially temp equal to pointer next. So because the address of this is present in the pointer next 400, so I gave temp equal to pointer next. So right now temp is pointing to this particular node. So here it is temp. Fine. Now what I have to do, I have to replace the address, whatever is present here, with the address 500. Means this 400 should be replaced with 500. How can I do it? Pointer next should be replaced with what? 500. This 500 is present in which particular block? Can you please tell me here? You can see here in the temporary block. Right now temp is pointing to this particular node, and here the next block of the temporary node consists of 500. So pointer next equal to temp next. So what is the address we have in temporary next here? 500. That 500 I am storing in pointer next. So indirectly what I did, this I have replaced with 500. Well, I am successful in doing that. So I have successfully replaced the value here. So the link between this is gone, but there exists a link between these two because it is pointing to 400. That I have to replace with what? Replace with this pointer 300. How can I do it? It's easy, I guess. Temp. So which I have to replace now? This particular block I have to replace. Means temp next. So I don't have any variable which is pointing to this node. So I have to take the help of this particular previous node. And previous node consists, I am pointing it using a variable called as temp. So temp. So which node I want to replace? The next node. What is the address? 500. And this address is present in which node? Next block. Temp next. So what is the temp next here? 500. So I have reached this node. And in this, what is the block I want to replace? This 400. That is previous block I want to replace. So previous. And it should consist of address how much? 300. 300 is present in which variable? PTR. So simple PTR. Your task is completed. So what happened now? This 400 is getting replaced with 300. So you got address 300 is the address of this particular node, and we have 500 which is pointing. So this particular node is removed, but I did not free that memory here. So how can I free it? Free. So temp. Okay, I hope you people got it how exactly this particular thing is working. Let me explain one more time so that it becomes clear for you people. You can understand it. So what you have to do here, first you are going to take a pointer, and pointer will be pointed to the node after which you want to delete it. So pointer has reached this particular location. What is the initial address we have here? 300. And what is the here initial address? 500. Same way here the initial address is, this is 400. So this is 400 here, and here you are having something called as 400. Okay, so now what I have to do, this pointer has reached to this particular node. First thing is I have to remove this, means I have to free this particular node. So then I need to have some variable which is pointing to that particular node. So for that, I'm using a temporary node. Temp equal to, so I want to point that temp to this particular node. How can I do it? Pointer next consists of address of this particular node. So pointer next. So what is pointer next consist of? 400. So that 400 I am storing in this temper. So right now, this is what we call it as temporary node. So this is a pointer is pointing to this node. Temp is pointing to this particular node. Done. Now what I have to do? Now it's very simple. Now I have to replace this particular next. Pointer next should be replaced with the address of this particular node, that is 500. Now if you see clearly, this 500 is present in which particular next block? Tempers next block. So simple thing is pointer next block. So pointer is pointing to this node. The next block consists of 400. I want to replace that with 500, and that 500 is present here. So temp next block. So what is the temp next block consist of? 500. So this 500 is going to come here. Where? Here. So pointer next equal to temp next. So here you are getting 500. So you have overridden that. Now you have to override this one. This 400 should be overridden with 300. How can I do that? So first I have to access that particular node, the 500, the address which is having 500. I have to first access this particular address, but I don't have any variable pointing to this particular node. So I have to take the help of this particular temp only. So what I have to do? Temp next consists of address of this particular node. So temp temp next equal to temp next means what is the address we have? We have 500. So I'm coming to this particular node. Sorry, not equal to here. So temp next. So I have, okay, let me write it one more time here. Temp next. So what is temp next? 500. So you have reached this. In this, what is the block I want to access? Previous block. So temp next arrow previous equal to, what is the address I need here? 300. Means 300 is present in pointer. So I'm going to write pointer. So now this has been replaced. This has been replaced with, from 400 it is replaced with 300. So there is no connection between them. Now this is a free bird. This node has been free and there is a connection between these two nodes. Now I have to free this. So simply I'm going to use free method. And in this, what is the value? I have to write here something like 400 now. So this has been accessed using a temporary variable. So temp, that's all. So these are the 3 steps which you people have to use in order to perform the task. 4 steps. That's it. So you can remove that element. Same way, you people can remove a node before a given node. Now this time, if you see here, the value is 4. Before that, whatever the node is there, I want to delete it. But here there is a small modification which you have to do. Same process, no changes. But small verification is there. What is that is, let us suppose I want to delete the previous value after 3. Here what is the what I'm exactly showing here is that before 4, what is the node I'm having? I want to delete this. I mean, I want to delete this node. Now let us assume, you just assume that, what if I gave the value 3? I want to delete the previous node. Now if you see here, this becomes the starting point, right? This becomes the first node. If I want to delete a node before 3, this becomes the starting point. Means if you are deleting this, this will become node 1. This is what we have to check. When you're deleting a before node, are you deleting the first node or not? Because if you're deleting first node, again, we have to make changes. This will become node number 1. So start should come here. So there are some modification, and here it should be X and it should be pointing to next. So here these modifications need to be done. For that purpose, we are doing a small logic here. If else statement I am going to use. Remaining process is same. Like for example, which node you want to delete. So let us suppose before 4, whatever the element is there, I want to delete it. So the value I'm giving is 4. While pointer data is not equal to value, keep on pointing. So pointer is initial at this location, and finally it has reached to the location before which the node has to be deleted. Fine. Now I'm going to take a temporary variable. So because definitely the node which I wanted to remove it, I had to free it. So temp equal to, so this is the one now. There, what did I take? Temp equal to pointer next. If you see the previous one after, what is the logic I've used? Temp equal to pointer next, because this is the node I want to delete. But in this case, the previous node I want to delete. So temp equal to pointer previous. So I mean this particular node. So this one, it is going to point it up. So right now the temp is pointing to this particular node. Fine with this statement. Now I just wanted to find out whether is it the first node or not. So this is what I'm checking here. If temp is equal to start. See, please understand carefully. Now temp is pointing to this. I am just finding out whether the node which I am present in temp, is it the first node which I am deleting it? If yes, if this is the first node you're deleting it, start equal to delete beginning. So you can see here, I'm going to the code delete beginning. So delete beginning in the sense, this code, I'm executing this code. Okay, this is the code I'm executing here. Start. See, you can see a delete beginning. This is the code I'm executing it. If the node which I'm trying to delete is the first node. So if temp is equal to start, what does that mean? Is it a first node or not? I'm checking it. If it is, then execute the function delete beginning, and that will perform the operation. So it will delete the first. If it is a first node, it will delete it. Remaining operation will be performed by that. In case if it is not the first node, then you perform the else statement. Now is temp is is this particular node is the first node here? No, this is not the first node. What can I do? Simply this condition fails. You will be executing the else part. What is the else part? He is having pointer previous equal to temp previous. Pointer previous. What do you mean by pointer previous? Pointer is pointing to this, and this node he is trying to modify it. Now, what is the address here? This is 100. This 100 should come here, and this 100 is present in which particular node? Here. Okay. So I hope you people are getting it. This is 100. This is 200. This is 300. Means this will have 300. So what I is doing in this particular block, pointer previous should consist of address of this particular location. So what are we are writing? Pointer previous equal to temp previous. So temp previous consists of value here 100, and that 100 I'm assigning to this. So indirectly now this 400 is getting replaced here with 100. Okay, I hope you got. So this link, the second link, what you're seeing is established. Now this has to be changed. Here you consist of value 200, and this 200 should be replaced with 300. How can I do it? Temp next. Here 100 in the sense this node. This node next block should be replaced with what? Pointer. That 300 is replaced. 300 is present in the pointer. So that I am writing it here in this particular case. Let me explain it once so that you can understand again once carefully. So what is the address we have here? 100. This address is 200. This is 300. Means this will consist of 300 and this will consist of 100, right? And here you will be having something called as 200, and here you will be having something 200. Now I have to replace this 200s. This 200 I have to replace this. So first I am going to do is I am going to assign this particular node with temporary variable. Temp equal to pointer previous. So pointer is pointing to the node before which I want to delete the node. So pointer previous consists of value 200. That I'm assigning to temp. Temp equal to pointer previous. So that is nothing but 200. So right now temporary is representing this particular node. Now if temp is equal to start, if it is a starting node, execute delete beginning method. So deleting from the beginning method has to be executed and it will perform the operation. But if it is not the first node, perform the second option, else statement. So then since this is not the first node, you'll be performing else statement. What is that? Pointer previous equal to pointer. So what I'm going to do is pointer previous. Okay. equal to temp previous. So I'm going to replace this 200 with 100. How? Pointer previous node equal to, what is the temporary here? Temporary previous node consists of 100. So temp previous. So that 100 will be coming into this. Done. So I have replaced it. Now I have to replace this one. But I cannot use start here because it may be a starting point here, but there is a possibility before 7 if you want to delete. If you want to delete a number before 7, then this doesn't becomes a start. So I should not be using this particular variable. So that's why how can I access then this particular node, this one? Simple. Temp previous, isn't it? So temp previous, because temp previous consists of address 100. So you'll be coming to this particular location. In this, the next block you're going to access it. Next equal to. So what is the value you should get? 300. And 300 is present or represented using a pointer. So simply I'm going to write pointer. Finally, a link is formed. This particular node is free. Now I have to free the memory. How can I do it? Free temp. That's it. So this is the way how we people can easily try to solve the particular problem. Okay, so you just practice this. It's very, very easy. The only thing you people have to understand the diagram, and based on that, you will be coming to know how exactly this particular thing is executing. So these are the slides related to that, how to do it. That's it. So this is the code what we have discussed here. This is deleting a last node. How to delete? Pointer will come there and simply will remove it and then the final block. And this is a code for that what we have discussed. And then finally we are deleting a node after a given node. So here I want to delete something called as 7. So I have deleted it. So this is a code for that what we had discussed earlier. Then deleting a node from a before node what we have here. Same process. And then finally deleting a before node. And this is what we have exactly seen here. So with this, we actually complete your double linked list. Okay, in the next session, we'll discuss about circular linked list, and the same way we are going to do. My suggestion is you people start working on this particular algorithm so that it becomes very easy for you people to understand. Because the more you're practicing it, the more you people will be easily able to understand it. And then finally, you will be able to write the code directly. All these codes, whatever I have shown you, if you club together, finally, you will be getting an entire code for deletion, insertion, for your circular linked list program. You'll get an entire program for your circular linked list where you people are performing operations such as insertion, deletion, and traversing and displaying and all everything, creating also. Okay, so just practice them so that it becomes easy. My suggestion is first take a diagram, whatever the diagram I'm showing, see it, try to apply to that. Then based on that, try to write the logic. Definitely you will succeed in that particular thing. So well, we'll wind up this particular session here. This is all for today's class. Thank you. Thank you for watching.